Hello class. So in this video, we're going to start on section 5.1. Now, section 5.1 is an introduction to integration. Now, in the previous section, section 4.9, we were talking about integration already, but in a way that related integration with antiderivatives, right? Because what we defined in the previous video was that the indefinite integral of a function, or the integral f of x dx, this was by definition all antiderivatives of f on some interval. So that's what we saw last time. And then I mentioned this notation is that we used, so this integral symbol and this dx, as I mentioned, this is going to be weird for us in the previous section, but now we'll be able to understand where this comes from. So what we're going to do is we'll define integrals instead of with the antiderivative way as the natural way it's defined. So we'll define integrals as ways of approximating area. And then we'll see how approximating area is related to antiderivatives, right? So right now it's kind of, it'll be kind of confusing. I'm approximating area, how is that related to antiderivatives? But you'll see that it is related. And in fact, that's what we call the fundamental theorem of calculus, right? It's this relationship between calculating area and antiderivatives, which is not obvious at all. That is why it's such a fundamental theorem. Okay? So that's the idea for this chapter, for chapter 5. We'll start to define integrals as ways of approximating area, and then we'll go from there. Okay. So before I start, we're just going to start with an example. Before I do that, I'm just going to give you or remind you of some things that maybe are not too obvious. Right? So let's say we have an interval, right, on the number line. So let's go here. So suppose we have an interval. Let's say we're going from 0 all the way to 8. And let's say I tell you, I want you to divide this interval into 5 subintervals of equal length. Or actually, let's do it easier, into 4 subintervals of equal length, right? So divide this interval into 4 subintervals of equal length. So this is the first thing we need to learn how to do. Right? It's actually pretty straightforward. You can probably just look at it and realize what you have to do. But if not, it's okay. Right? Let's say you're tasked to do something like this, divide an interval into 4 subintervals of equal length. Well, the thing you want to find is what's the length. Right? If you know what the length is, you can just start from 0, add that length, 4 times or as many times as you need, and you should be good. Right? So really, when they ask you a question like this, what you want to answer is, what is the length to choose? And in general, the formula you want to use is you take the endpoints of the interval, whatever they are. In this case, there's 0 and 8. You subtract them and divide by how many subintervals you want. So you're going to take the endpoints, subtract them, and divide by the number of intervals, of subintervals that you want. And that's how you do this. Okay. So what do we get here? Here we have 8 minus 0 is 8 divided by 4. So 8 divided by 4 is 2. Okay. So if we want to divide this interval into 4 subintervals of equal length, the subintervals must have length 2. So what do you do after that? Well, you start at 0, you add 2. That's the first subinterval. Add 2 again, so that's 4. That's the next subinterval. Add 2 again, that's 6. That's the next subinterval. Add 2 again, we're at 8. So it's as simple as that. You first find the length, then start on the left endpoint and start adding that length. Now, for our purposes, this interval is usually going to be the x-axis. This is going to be the x-axis. So this interval length, it's really a change in the x values. And so we're going to denote this as change. So this is delta, change in x. So you can read it delta x or just change in x. Okay. So in general, if you're given an interval a to b and you want to divide it, so let's say they ask you to divide the interval ab into n subintervals. of equal length, then what do? Well, the length of the interval, that's the first thing you want to find. The length of the interval is always going to be, and again, I'm going to just call it change in x from now on. Remember, this is the length of the interval, of each interval. This is always going to be given by this formula. Subtract the endpoints and divide by the number of sub-intervals you want. Okay. Once you have that, then how do you divide it? Well, you start at A. So start at left endpoint. In this case, A. And simply add change in x as many times as you need until you get to B. That's the idea. And you see that's what we did here, right? So we found the change in x to be 2. I started at 0, added change in x once, that took me to 2. Added change in x again, that took me to 4. Added change in x again, that took me to 6. Added change in x again, that took me to 8. And it's as simple as that. Now this might sound, or it might seem a little bit weird. Why are we talking about this? Well, we're talking about this because the way we approximate area is going to be related on how we partition the interval where the area is located on, whatever shape it is that we're working with. So this is the first thing to know. Now that we have this out of the way, I'm going to start this in another video. So first, make sure that you understand this, right? Just how to divide it, a interval, a sub b, a to b, into n subintervals of equal length. Right? Once you know that, again, it's pretty straightforward. Just use this formula. Now we're going to use it to actually approximate area.